Welding with Mr. Supanik. Today's lesson is going to entail chapter 11, and this is with shielded metal arc welding, and this is going to talk about depositing a continuous bead. A couple of objectives for today. We're going to identify general considerations for arc welding. We're going to describe methods for crater control. We're going to talk about how correct undercutting, overlapping, and arc blow, and then the procedure for cleaning welds. First thing, heat from the arc melts the base material, forming a crater, which molten base metal and filler metal can flow to create a quality weld. So when you're doing this, your weld is going to be approximately a quarter of an inch wide, quarter inch to 5/16. So the penetration into your base material should be about half the width of that particular weld. So if you have a quarter of an inch weld, the thickness into that base material is going to be about an eighth of an inch. Okay, so that's about how far you're going to penetrate into that material. Arc length is the distance from the tip of your electrode to your weld pool. Now, arc length, if your machine is set at 115 amps, okay, the closer that you get to your material, the shorter your arc length is going to be, and the cooler your weld is going to run. Okay, the farther you get your rod away from your workpiece, the hotter that your weld is going to feel like it's burning, and the you're going to see the difference in your weld. So take a look at the first weld. Okay, you have nice even ripples, right? This is your correct arc length. Now, if we get our arc length too long, in addition to a little bit of a pointy weld, you're also going to get a little bit of excess spatter depending on what rod it is that you're using. And then if your arc length is too short, your weld puddle is going to be smaller. Therefore, you're going to get less penetration into your base material. Therefore, you're not going to have as good of a weld. The correct travel speed produces a smooth weld bead with evenly spaced ripples. Okay, the first one, you have your current and your travel completely normal. Okay, this looks like what's called a stack of dimes. Okay, laying a stack of dimes is what you're going to be aiming for here. Okay, now let's say that your machine or your electrode itself, 115 amps is normal operating range, and you're running on 105 amps. Okay, that would be maybe a current that's a little bit too low, so your bead's going to look halfway decent, but it's going to be too small. You want that rod to be about 2.5 times the diameter of that particular electrode. Okay, your current being too high, so that's your amperage being too high, that's where you're going to get a lot of undercut into your weld material, like this little area right here. Okay, you're going to get some excess spatter. And your travel speed too low, or too slow, I'm sorry, the travel speed too slow is going to make a weld too big. And what one of the downfalls of that is, if you're welding on a thin piece of material, then you're putting too much heat into that material. Okay, so you're going to have a chance of blow through. Okay, you're going to start to distort that material. Okay, and then the last one we have here is our travel speed too fast. If you're welding and your travel speed is this speed down here, you're doing a couple of things. Okay, number one, your bead size is not the correct size. Number two, you're going too fast, and you're not putting any reinforcement into that joint. Okay, you're going to get excess undercut on the toes of your weld, and that weld is not going to do anything. It's literally just sitting right on top of that weld. Okay, so the correct electrode angle is required to make proper weld. If you're working in the flat position, number one, we're working on what's called a drag travel angle. Okay, in that drag travel angle, you want to have a travel angle of between 10 and 15 degrees. Okay, Your crater, it's a depression in the molten metal made by the arc. So as soon as you strike that arc, it instantly liquefies that base material, creating a crater. And then your filler metal takes that crater, fills it back in, and bonds the base material to your welding electrode. That's what creates a nice weld. If you need to restart your electrodes, you want to start about a half of an inch in front of that weld. Okay, and this is all in one motion. You're going to start about a half inch in front of that weld, strike your arc, and you're going to move it back into that crater from where you left your arc. Some people like to run a little circle in there. Some people like to run a little J. This is going to be up to you to try and figure out what's going to be best for you. So you're going to come right back into the crater of that weld, pause for just a slight second, and then you're going to continue your weld as if you never stopped. Undercut is the result of welding with excess current or traveling too fast or the use of an improper work angle. So if you have something more than 15 degrees travel angle, and you have a, let's say, less than 90-degree work angle, okay, you're putting more heat into one spot on that particular piece of material, and what's going to happen is you're taking away that base material, but you're putting that filler material in a different location because your work angle and your travel angle is off. Bad things can happen with undercut. You can trap slag. It's the most important part. You can, by not filling it in, you can have defects in your base material, which could cause for failure at a later date. Overlapping, or also known as cold lap, occurs when the current is set too low and molten metal is deposited without actually fusing to the base metal. So that is simply a weld sitting on top of your material rather than actually penetrating into your material. Arc blow is the deflection of the welding arc by magnetic forces that occur due to current flow. So typically, in order to try and prevent arc blow, you want to try and take your workpiece and put it to the side or even towards the top of your electrode here, or your workpiece. A lot of times what you can do is you can, when you start to get arc blow, you can stop. You can turn down your amperage slightly. You can move your ground clamp and then restart up your electrode and continue working. Strike the weld with a chip and hammer and then rub it with the wire brush. Okay, make sure when you're striking that weld with a chip and hammer, you're not hitting it as hard as you can. When you're hitting it as hard as you can, what you're doing is putting indents in the weld itself, and then you're causing defects. Okay, if you chip it slightly from the side, eventually that slag is going to come off, and then you're going to take that wire brush. You're going to wire brush directly over top of that, clean that material. Couple things to remember here. Use the right electrode for the right operation. The arc length should be approximately the diameter of the electrode. So if you have an 1/8 of an inch electrode, your arc length, which is the distance from the end of your electrode to your workpiece, you're going to have about an 1/8 of an inch. Maintain travel speed that is just fast enough to produce evenly spaced ripples. So if they're not evenly spaced, slow down a little bit. If they're evenly spaced but they're too wide, speed up a little bit. Use the correct current for the particular electrode. The depth of penetration should be 1/3 to 1/2 the total thickness of the weld bead. So if you have a 1/4 of an inch weld bead, the depth of penetration should be about an 1/8 of an inch. Make sure the molten metal from your electrode fuses completely with the base metal. Restart the electrode 1/2 inch from the front edge of the previously made crater, and avoid undercutting and overlapping of the weld joint by using the correct current and electrode angle. Prevent arc blow by turning your machine to AC. That's going to be the best option. But if you can't do that, you can move our ground clamp. We can adjust our current settings as long as we're not adjusting them too low. And then with cleaning slag from a weld, direct chipping away from the body, eyes, and the face is always recommended. If you're chipping towards yourself, what's going to happen is you have a great chance of chipping that stuff and having that slag laying on your face, going down your shirt, and burning you directly on the skin.